Greetings everyone, my name is Amriket and me and my teammates will be presenting our projects titled Rogue Access Point Detection and Tracking System using Trilateration Algorithm. So we will have introduction, problem statement, objective and goals, literature review, methodology, and conclusion. So IP is an unauthorized wireless access point that has been installed on a network without the knowledge of network administrator. For example, IP might be set up by nearby businesses that use a company network to gain free access. So the presence of IP in tertiary institutions can lead to a wide range of security issues, including unauthorized access to sensitive data, man-in-the-middle attacks, and denial of service attacks. These security breaches can have severe consequences, such as the leakage of personal information, academic research, and intellectual property, as well as the disruption of critical network services. Hence, the objective of this project is to identify the best method for detecting IP in the tertiary institution and also develop an efficient system using trilateration algorithm that can track IP and prevent unauthorized access to the networks. So, moving on, the previous works on IP detection methods are client-side approach, server-side approach, hybrid approach, dual authentication stages framework, analyzing received signal strength patterns, and the tracking method is by using trilateration algorithm by Kawasme and Awad. And so we will combine them to have a fully functional tracking and detecting IP system.
My name is Lee Chiu-min, and in this project, I'll be presenting methodology for detections, methodology for trackings, and conclusions. So now, let us hop into the methodology of detections. So, as you can see, here are the approach that we'll be taking to optimize our detection strategies. It's a three-step plan, and we follow these key strategies in order. Firstly, evaluate, then compare, and lastly, implement. Let me walk you through each step. Firstly, evaluation is basically just identifying and categorizing the available detection systems by considering factors such as type of detections. Secondly, we will set up the criteria based on the context in which each detection will be used. We will take into account to their goals and the result we found during the evaluation. Finally, once we have compared the detection system and made the decisions, we will move on to implementation stage. We will create a detailed plan that outlines all the necessary steps to successfully put into chosen system actions. Next, I will introduce you to our proposed road access point detections and tracking system using trilateration algorithm. This method is based on the research conducted by Kawashme and Awad. The core idea of our system revolves around using three stationary VLAN stations, known as reference node RNs, and a centralized localization server. The RNs are strategically placed at known location connected to the central server. Once a mobile access point is detected, each RN listens to the standard beacon frame sent periodically by the MRAP to announce its presence. The received signal strength indicator associated with these three beacon frames is measured by the RN radio hardware and sent to the central server. The server then estimates the distance between the MRAP and each RN using the log model's shadowing path loss model. With the three estimated distance, the localization employs a triangulation algorithm to the pinpoint to the current location of the MRAP. Moreover, to estimate the MRAP direction and speed of movement, we perform linear regression of the last WD consecutive estimated locations. Here, WD is another parameter that needs to be optimized. To ensure the system is effective, we need to carefully determine the optimal values of WO and WD. Based on a typical rate of the beacon frames and expected speed of MRAP movement, we aim to keep these parameters relatively small. So, in summary, our rogue access point detection and tracking system has the potential to make a significant impact in securing network against rogue access point, thereby ensuring a safer and more resilient network environment. Thank you.